right, the next thing we're going to do is section 2.3, and we're going to be applying our knowledge with solving equations to real-world applications. Many times, students always love to ask their math teachers, like, when am I going to actually use this in real life? And chances are you're not going to actually use everything you learn in school every single day of your life, but a lot of the times, with math in particular, you're basically we're helping you create a knowledge base and a toolbox for you to solve real-world situations like these below. So one of the most common used math concept is discounts and markups. When you're going shopping and you have X amount of money and you want to know if you can afford to get this item. Well, what we're going to do first is use mathematical models to solve business-related problems, things that actually can apply to your real life every day if you were to go shopping every day. So first thing is a markup. So if something is being marked up, that's how much money is being added to it. So basically, companies take items and they buy them or create them, and it's called wholesale. So that's like whatever the price is to make that item or to buy it from somewhere else, it's called wholesale, and then they mark it up. And the reason why they do that is so that they can make a profit. A profit is the amount of money they would make, which is basically the amount of the markup, because they take it for this amount of money or buy it for this amount of money or make it for this amount of money. They mark it up and then they sell it at a higher price so that that money in between goes into their pocket. So the markup on a consumer item is the difference between the cost a retailer pays for that item and the price at which the retailer sells the item. And then the markup rate is the percentage. So the markup is the actual amount in dollars, and then the markup rate is the percentage of the original cost. So for this section, I'm going to be explaining an example and showing you how to solve it, and then I'm going to be asking you to stop your video and try the next one or the next few before pressing play again, so you can get practice trying these on your own before I just go over all of them. A lot of the times, trying things and either being successful or not successful the first time, once you see it be done right in front of you after you try it, it'll commit to your long-term memory. So for the first one, we're going to do this one together, and then I'm going to have you stop your video. So example 1, find the markup or markup rate. The selling price of a jacket in a department store is $157.14. The cost of the jacket to the store is $130.95. What is the markup? So basically, to solve this type of problem, we would find the difference of what they're selling it for and what the cost was to that company. So the first step is to subtract $157.14 minus $130.95, and then this answer is the amount of the markup. The markup is $26.19. This is also known as the profit. The markup is how much money they're increasing the price before they sell it, which is also known as their profit. Now we're going to be finding the markup rate. This represents the percentage of the original jacket. The original jacket is this number right here. So this is the original. This was the cost of the jacket to the store. So whatever it cost to make it or wherever they got it beforehand, that's the original. So what we do is we take the amount of the markup, the $26.19, and we divide this by the original amount, which was $130.95, to get a decimal and eventually a percentage of what the amount of the markup is. So when I divide this in my calculator, which calculators are totally cool to use now, we get 0.2. And moving this and making this into a percent, adding a 0 here and adding the percent sign, this is a 20% markup rate. So step 1, to find the markup, you subtract the two numbers, and that number will be the amount of the markup. Step 2, to find the markup rate, you take the markup number and divide it by the original. What I want you to do is press pause and try the next one on your own. Okay, let's go over letter B together. So the department store sells a sweater for $60. The cost of the sweater to the store is $35. What is the markup? So we're going to subtract 60 minus 35, and we're going to get that the markup is $25. And then we want to find the markup rate. The markup rate means you take the amount of the markup, $25, and divide it by the original price. The original price is the cost to the sweater, the cost of the sweater to the store. So we divide this by 35, which is the original price of the sweater. When I do that, this ends up not being perfect. When I divide this, you're going to get a decimal, and I decided to round to the nearest hundredth. So this is going to be about 71.43%. When we have a more specific activity, and I'll be telling you what to round to, like the nearest tenth, the nearest hundredth, the nearest thousandth. So it's important to follow those directions. I did not give you directions for this one, so if you just said 71%, that's correct. If you said 71.4%, that's correct. If you said 71.43%, that's correct. So there really is a bunch of different answers for this one since I was not specific in how to round. Okay, moving on to example 2. We looked at markups. Now let's look at the opposite of that, which is discounts. So the discount is based on the list price. So it's a reduction from the original price. And the discount rate is still a percentage of the original price. So now we have in letter A department store sells a beach towel for $32. On sale, the beach towel sells for $24. What is the discount? To find the discount, we do the same process. We subtract the two numbers, 32 minus 24, and we're going to get that the discount is $8. And then to find the discount rate, we take the amount of the discount, which is $8, and divide it by the original price of the beach towel. The beach towel originally was $32 before they put it on sale. So we would take 8 and divide it by 32. When I do that in my calculator, I get 0.25, which then turns into a 25% discount rate. Okay, what I want you to do now is pause and try letter B on your own. All right, let's go over letter B. A shoe store sells a pair of athletic shoes for $75, and then it goes on sale for $45. What is the discount? So I'm going to subtract the two numbers, and the discount is going to be $30. And then to find the discount rate, I divide the amount of the discount, which is 30, by the original amount. The original amount of the shoes is $75 before it goes on sale. When I do that, I'm going to get 0.4, which turns out to be 40% of a discount. So 40% off. All right, and then the last one on this page, letter C. We have here, if a product is discounted by $4 and is selling for $16, what was the original price? Okay, what is the discount rate? So the product is discounted by 4, and now it's selling for 16. So I know that if I said this is the price of it, X, I know that if it's discounted by $4, the original price was taking $4 off of it, and now it's equal to 16. So I know that the original price of this item was $20. So if the original price was $20 with a $4 discount, to find the discount rate, we would take the amount of the discount, which is $4, and divide it by the original amount, which we just found was $20. That would be a 20% discount rate. So I didn't really label my answers here. This problem right here helped me determine that the original price was $20. And then the second problem helped me determine that the discount rate was 20% off. Now I know that that's a coincidence that both the answers are 20, but that's not going to happen all of the time. All right, in example 3, now we're looking at a different type of problem. We're looking at labor rate. The bill for the repair of an automobile is $380. It Included in this bill is a charge of $2.75 for parts and the remainder of the bill for labor. The charge for labor is $35 per hour. How many hours were spent in repairing the automobile? So what I'm going to do first is determine that I'm going to be using X, and X is going to represent the amount of hours, since we're trying to determine how many hours were spent repairing the automobile. And I'm going to create an equation. I know that the total amount for the repairs is $380. So $380 is going to be equal to the just plain charge for $2.75 plus $35 per hour for the repair. So here's my equation. 380 equals 275 plus 35x. To solve this equation, I would first subtract both sides by 275. All right, and then when you do this, you will get 105 is equal to 35x. Oops, I forgot 5. And then the last thing you would do is divide both sides by 35. And you're going to get x is equal to 3. So this means that 3 hours were spent fixing the automobile. Letter B is very similar to this, so why don't you pause the video and try letter B on your own. All right, let's go over letter B. An auto repair bill of $338 lists $170 for parts and the rest for labor. It took 6 hours to repair the automobile. What is the hourly rate for labor? So in this case, X, our variable, is going to represent something different. It's going to be the hourly rate. And we know that the bill is $338 total. And the $170 is just for the parts, and the rest of it is labor. So we know it took 6 hours to repair, so I would multiply 6 times however much it costs for the hourly rate, and then this would be my equation here. 338 equals 170 plus 6x. Step 1, I would subtract both sides by 170. When I do that, I get 168 is equal to 6x. Then I divide both sides by 6, and I'm going to get my answer is $28 per hour. All right, moving on to some more examples. Example 4 is all about classic rate problems. So we are going to be using the formula distance equals rate times time for all of these problems. For instance, if you travel at a constant rate of 55 miles per hour for 45 minutes, the total distance you travel is given by distance equals rate times time. We want to figure out how many miles you would be traveling if you are going 55 miles per hour for 45 minutes. So we're trying to figure out distance in this problem. We are given the rate. The rate is 55 miles per hour. We are given the time. The time is 45 minutes. But we cannot multiply by 45 because if our rate is in miles per hour, we need to change minutes to be hours. To do that, I know there's 45 minutes that we're looking to convert, and there's 60 minutes per hour. So I could use the fraction 45/60ths, which is the same thing as 3/4. So I could multiply 55 by 3/4, and that's going to end up being 41.25 miles. Letter B is a little bit different than letter A. In letter B, we're still using the formula D equals R times T. But now we're looking for how long will it take. So we're looking to find time here in this problem. If we bike 30 kilometers at a rate of 18 kilometers per hour, so my distance is going to be 30 since we are riding 30 kilometers My rate is 18 kilometers per hour, and we're trying to find time. So for this one, the equation would be 30 equals 18t. To solve this one, I would divide both sides by 18, and we end up getting that time is going to be equal to 1 2/3 hours, or 1.6 repeating. What I want you to do now is stop the video and try C, D, and E. All right, letter C. A train can travel a distance of 252 kilometers in 2 hours and 15 minutes without making any stops. What is the average speed of the train? So for this one, I have here that it is, oh, sorry, I'm looking at the wrong one. We have 254 kilometers in 2 hours and 15 minutes, and we want to find the average speed. So if I want to just find the average speed, what I can do is just divide these two things together to find the speed. So I would take 252 kilometers and divide it by the time here. But the time is all in different units. So if we want to find the average speed in hours, kilometers per hour, I would have to change 2 hours and 15 minutes to be in hours. To do that, I could take 2 hours and 15 minutes, convert that to hours by taking a mixed number and making it 2 and 15/60ths. And 2 and 15/60ths really equals 2 and 1/4. So I could divide 252 kilometers by 2 and 1/4 hours, and my answer will be in kilometers per hour. This would equal 112 kilometers per hour. So that would be your answer in kilometers per hour. You could also do it in minutes as well. It didn't specify, but usually our time is per hour, not per minute. In letter D, we have 2 trucks leave a depot at approximately the same time and travel the same route. How far apart after 4.5 hours, how far apart are they if their average speeds are 52 miles per hour and 56 miles per hour? So for the first truck, I know that it is going 52 miles per hour. So to see how far it goes in 4.5 hours, I would multiply 52 times 4.5 and get 234 miles. For the second truck, it's going 56 miles per hour. So if I multiply 56 times 4.5 hours, I know that it's going to travel 252 miles. So if the first truck traveled 234 miles in that time, the second truck traveled 252 miles at that time, I would subtract these two mileages, and my final answer would be 18 miles apart. Same type of situation for the second one, but now we're talking about airplanes. We are trying to figure out how far apart they are after 1 1/3 hours. If the first one is traveling at 480 miles per hour, and the second one is traveling at 600 miles per hour. Well, when I multiply 480 times 1 1/3, I get 640 miles. For the second one, I get 800 miles. So I would subtract 800 minus 640, and I'm going to get that they are 160 miles apart. And the last section in, the last type of example in this section is simple interest. Now notice, all of these problems are completely different. You have to take each situation and apply your knowledge for all of these real-world examples. Not every example is going to be exactly the same. Some of you will be frustrated by that. Others will be open to the fact that each problem is solved a little bit differently. So we are using this formula here for these following equations and following problems. And this is about simple interest. Simple interest is like the amount of money you have in a bank account, or you get a loan, and here's the amount of money that you would owe, or here's the amount of interest you would owe. Interest is basically extra money you have to pay if it's a loan. Interest is also money that comes into your bank account for free when you bank with a certain company. Principal is the amount you deposit originally, or it's the amount that's put onto a loan originally. Rate is the percentage of the interest, and it's always represented in decimal form. And time is always in years. So we want to find the annual interest rate. So we want to find the rate. So using the equation, interest equals P times R times T. I already know from this example, from the first part of the sentence, is that we're trying to find the interest rate. That means that when we're replacing numbers in for all of these variables, R will remain a variable. We have here all the other information that we would need to replace in for the I, P, and T. So it accumulated $400 interest. That means that I is going to be $400. It says in 2 years, okay? So that means that T is going to be 2. And it tells us the principal of $2,500. So $2,500 I'm going to squeeze right here. So the equation I have to solve is 400 equals 2,500 times R times 2. Let me simplify this. 2,500 times 2 is 5,000. So the right-hand side should be 5,000 R. The left-hand side is 400. Now we're going to solve this equation. To solve 400 equals 5,000 times R, I would divide by 5,000. And when I do that, I'm going to get a decimal. My answer is 0.08. Now remember, we are finding the rate in this problem, so I would convert this to be a percent. This is an 8% interest rate. Why don't you pause the video and try number 2? Okay, let's go over number 2 together. We deposit $8,000 and earn $300 in interest in 6 months. We want to find the annual interest rate for this account. Okay, so we deposit $8,000. That's the principal amount. I'm going to replace $8,000 in for P. We earn $300 in interest. That's I. I'm going to replace $300 in for I. They give us the time, 6 months. Unfortunately, time always has to be represented in years, so I'm not going to put a 6 here. That would be wrong. Instead of putting 6, which would represent 6 years, I'm going to put 1/2, because 6 months out of 12 months in a year is equal to 1/2 of a year. So I have 8,000 times R times 1/2. And now I'm going to solve for R. Simplifying this equation, 8,000 times 1/2 is 4,000. So I have 300 equals 4,000 times R. Solving this, I would divide both sides by 4,000. And in my calculator, I'm going to get that R is equal to 0.075. This is a rate that I'm then going to be converting into percent form. This is 7.5%. And then letter B is asking, at this rate, how long would it take to earn $800 in interest? So using the same exact idea, but now I want to know in the formula how long it will take to earn $800 in interest. That means I'm going to replace I with 800. It's still the same exact principle, which is 8,000. We now know the rate is 7.5%. When I put it into the formula, I have to use the 0.075 because it has to be in decimal form. But now I'm solving for time, how long it will take. To solve this, I would simplify by multiplying 8,000 by 0.075. And then I would divide 800 by that, and I'm going to get that time is equal to 1 1/3 years, or 1.3 repeating years. Now that was a lot of stuff, a lot of different examples, and each problem is a little bit different. But with time and practice, we will get used to solving all of these real-world applications with the knowledge we have with solving equations.